Class, welcome to the next math lesson in Eureka Math Module 2. We're in Lesson 13. Lesson 13 is the angle sum of a triangle. The angle sum of a triangle, the inside angles of a triangle and how we add them up, some rules about them and how we can find missing angles in a triangle, missing angles in diagrams. So we are in pages 137 to 148 of your student book, so please get those pages out. Get your note page out and start copying down the notes you see on the screen in front of you so that we can get to work as soon as I am done discussing them. So the road so far, specifically in Lesson 12, the last lesson we did together, we learned about different types of angles. We learned about corresponding angles, alternate interior angles, and alternate exterior angles. And we learned about how corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. And we learned how to prove those with translations and rotations. So those are the rules, the laws we learned in the last lesson, which angles in a diagram are equal. We're going to use that information today to find missing angles. We're going to use corresponding angles, alternate interior angles, and alternate exterior angles to find missing angles in triangles and other diagrams. That is what we're doing today. We're using our knowledge that we learned in Lesson 12 to find missing angles in diagrams. This helps us with geometry. It will definitely help you in geometry in high school. This helps with blueprints and designs for different buildings or different machines, figuring out the angles, figuring out how to do this stuff. Understanding angles is important to a lot of things, just how things move, how things run, where things should go. So we're spending some time figuring out how to find missing angles. Let's see, the last time I think I used this is when I built like a little step stool for my daughters to reach the sink to wash their hands after using the restroom. So finding missing angles will help you do a lot of like kind of random things. So that's what we're doing today. We're using corresponding alternate interior, alternate exterior to find missing angles. There are a few things, important things that you probably want to remember for the lesson today. Important things to remember. A straight angle is what we call a straight line. A straight angle is also, you might call it a straight line. It is also called a straight angle. And there are exactly 180 degrees in a straight angle. Exactly 180 degrees in a straight line. You need to remember that for today's lesson. That is a law. There's 180 degrees. That's something important to remember all during today's lesson. That is a fact you probably should memorize. 180 degrees in a straight line, also called a straight angle. The next thing you should remember is that a right angle has exactly 90 degrees. A right angle, a perfect capital L shape, has exactly 90 degrees. That is something you should have practiced. You should have learned in 5th, 6th, and 7th grade. So hopefully you remember that a right angle has exactly 90 degrees. It'll help you today. So a straight angle is 180 and a right angle is 90. It is also important to remember that every triangle, every single triangle ever, if it is a triangle, if it has 3 sides, all the interior angles of the triangle, there are 3 inside angles of a triangle, and every triangle, the inside angles always add up to make 180. A triangle has 180 degrees on the inside. You need to know that. A triangle has 180 degrees on the inside. So those are 3 facts that you should remember and that will help you on the lesson today. Those are also 3 facts that I believe you covered in previous years. I'm just reminding you about them today so that you can use them as we are kind of problem solving today and finding missing angles. So those are the notes, what we've done so far, what we're doing today, and some important things that you should remember for today. If you need to, pause the video right now, catch up on the notes, and maybe if you need to, send me a question about the notes if you have any questions. But to pause the video, and then when you come back, we'll be ready to start the lesson and finding missing angles. Okay, if you pause the video to review your notes and to catch up, thank you. But let's move on to the actual work of the day. A little bit of concept development on the top of page 137 in your on your workbook. So this is just telling you the top of the page, just telling you one of the important things I told you in your notes, that all triangles, isosceles triangles, scalene triangles, right triangles. This is isosceles because the two sides are the same. This is scalene because all three sides are different. This is a right triangle because it has a right angle. But all triangles equal 180 degrees. I told that to you in the notes. They're just telling it to you in the book. Just an important reminder that all triangles equal 180 degrees. And they have another thing right here, that in the right triangle over here, you know, just as a little extra practice today, if angle 8 is a right angle, angle 8 is 90 degrees exactly, which means angle 7 and 9 together, angle 7 plus angle 9 has to equal 90 degrees also. That's kind of a process of elimination thing. That's kind of a little logical thing. Because if this is 90 degrees and everything is 180, then these two together have to be 90. Because we do 180 for everything minus the 90 right here means there's 90 left over for 7 and 9. So there's going to be some logic puzzles today. So you're going to have to think logically, you have to pay attention, and kind of figure things out a little bit with angle sums. But that was just a little bit of a quick reminder that everything equals 180 and a little preview about the logical thinking you will need to do for this lesson. Well, let's move on to the activity where they give us a triangle. It says, let triangle ABC be given. So they give us triangle ABC. So right here, they give us triangle ABC, which I am outlining in blue. On the ray from B to C, take a point D so that C is between B and D. So they just stretch out this BC to make ABCD. So they just kind of stretch out the bottom of the triangle, make it keep going, and put a D so that C is in the middle. And then through point C, draw a segment parallel to AB. So they make another line. So they stretch out the bottom, and then they make a line up here. So we will stretch out the bottom right here. And then they make a line going up starting at C. And this CE is parallel to AB. So we know AB is parallel to CE. So line AC is now the transversal, which is a word you remember from the last lesson. So you see, let me rotate my paper a little bit so you see this a little bit. AB right here and CE are parallel. So now this AC is the transversal. So you can see how this kind of works from yesterday, how it's kind of connected to yesterday's. We have parallel lines AB and CE, and we have a transversal that cuts the parallel lines. So that is going to help us with the rules. Like I said, we're going to talk about corresponding, alternate interior, and alternate exterior angles. And to do those, remember yesterday we needed parallel lines and a transversal. Part A just says name the 3 interior angles of triangle ABC. Now, when you name angles, well, let's label the 3 interior angles. We need the 3 inside angles of the triangle. Here's one that I labeled in green. Here's another one that I labeled in pink with 2 lines. And here's the 3rd inside angle that I made red with 3 lines. Those are our 3 interior angles. Now we need to name them. When you name angles, you use the angle symbol, which is just a small angle like that. Now I'm writing in green, which means I want this angle right here. When I label this angle, it's going to be 3 letters. But because the angle is close to A is going to be the middle letter. So this is angle BAC. Because it's B, A in the middle, and then C, and that is this angle right here. A is in the middle because that's the angle next to because that's the letter next to the angle I'm talking about. So this pink angle down here is going to be angle ABC. B is in the middle because that's closest to the pink lines. Our 3rd angle right here, the red one, is going to be angle ACB. And C is in the middle this time because C is closest to the red angle. That's how we name angles. We use the angle symbol and we use letters. And it's very important that you put the right letter in the middle. Now you are allowed to switch it up. So like for the green angle, I could do angle CAB. The important part is that A is in the middle. I can write it backwards. So for the pink angle, I could do angle CBA because the important part is that the B is in the middle. And for the red angle, I could do angle BCA because the important part is that C is in the middle. So that's all you had to do for part A was just name the angles. For part B, we need to name a straight angle. And you'll remember in your notes, I told you that a straight angle is just a straight line. So let's find 3 letters that make a straight line in the diagram. Remember, an angle needs 3 letters. So we need 3 letters that make a straight line because a straight angle is a straight line. So I see just the bottom of the diagram is a straight line with 3 letters, B, C, D. So the straight angle is angle BCD because BCD all in a row make a straight line. You can also put angle DCB. It's the same thing except for some people will read this way, start with BCD and read that direction. Some people might read it the other direction, start with D and then go DCB. Both ways are good because if they are both the same straight angle and C is in the middle, and that's the important piece. So we named the angles. Now to do the work with the angles, we need to go to page 138 and see what the next thing is because there is 3 more activities we're going to do with the diagram. So part C, what kind of angles are angle ABC and angle ECD? So what kind of angles are those? Well, let's look at the diagrams. Angle ABC is right here. It's our pink angle. Angle ABC is our pink angle. And angle ECD, start with E, go to C, and go to D. So angle ECD is right here, which I'm going to label my pink angle. What kind of angles are our pink angles. So we have angle ABC, angle ECD. They are both pink with two lines. What kind of angles are those? In other words, what angles that we learned yesterday are they? It might help you if I rotate it like this so that you see the parallel lines. So if you see the parallel lines, it might help you, but it might also help you if I get out my transparency and I trace angle ABC. Because if I do that, you can see I can just slide it down to make ECD. And you should remember from yesterday that when you slide it down like this, that's a corresponding angle. So angle ABC and angle ECD are just a slide away from each other. So angle ABC and angle ECD, they are what we call corresponding angles. And then the next question, what does that mean about their measurements? They are congruent. They are the same measurement. Congruent means same measurement. That's what we know because they are corresponding angles. Might help you to see the corresponding angles if you stretch out the sides to show the parallel. I don't know if this will help you much, but if it helps you a little bit, if you stretch these sides out right here, stretch out the angles, and stretch out the transversal, you can see maybe a little bit better that angle ABC and angle ECD are corresponding angles. Let's look at part D. What kind of angles are angles BAC and ECA? So let's find BAC and ECA. Well, BAC right here is our green angle right here. BAC, A is in the middle, so it's our green angle with one line. And we also need ECA. ECA is this angle right here with the green line. So our one green line is angle BAC and ECA. So you see these angles right here. What kind of angles are those? From lesson 12 from yesterday, what kind of angles are those? And let me stretch out the transversal so it might be a little bit easier to see. And let me rotate the paper a little bit so our parallel lines are side to side. This green angle and this green angle, I can even point with my pen so my fat fingers are not in the way, as long as I don't mess up the camera. Let me make sure I didn't mess up the camera too bad. So, let's see. Okay, so we have them parallel to each other. We have the parallel lines, and you can see right here, angle BAC, the green one with one line, angle ECA. What are these kind of angles? Right here, you can see that they're on opposite sides of the transversal, and then they're the inside of the parallel lines. Opposite sides of the transversal on the inside of the parallel lines. So these green angles with the one line, what kind of angle are those? They are alternate interior angles. We learned about them in lesson 12. They're alternate interior angles. They're on opposite sides, alternate, and they're inside the parallel lines, so that's interior. So if they are alternate interior angles, that we know. What about their measurements? They are congruent. Same measurement. Same measurement. Okay, now we get to part E. We know that the measure of angle BCD equals BCA plus ECA plus ECD, and all that equals 180 degrees. So let me show you that. Angle BCD, which remember is our straight line. So they're saying this straight line right here equals the three pieces. So our straight angle right here equals the red angle plus the green angle, plus the pink angle. So red, green, and pink together right here make the straight angle. Red, green, and pink make the straight angle. That's what they're saying. So we have red, green, and pink make our blue straight angle that we did down here. Red, green, and pink together make the blue straight angle. And so that means it equals 180 degrees. So red, green, and pink equal 180 degrees because they are all make the straight angles. Now we need to, so if I say that red, green, and pink together make the straight angle and 180 degrees, that shows us what happens with the triangle too. Because if you look, red, green, and pink make 180 degrees, but inside the triangle, inside triangle ABC, also has red, green, and pink. So this is how you prove that a triangle has 180 degrees. Because red, green, and pink made a straight line to be 180 degrees, but red, green, and pink are also in the triangle. Red, green, and pink are also in triangle ABC, which is also, we know, has to be 180 degrees because red, green, and pink make 180 degrees. So this activity right here was supposed to prove to you that a triangle has 180 degrees. I told you a triangle has 180 in the notes. I told it to you up here, but now I just proved it to you with this. Because red, green, and pink make a straight line, and we also have red, green, and pink inside a triangle, we know a straight angle and the triangle are the same, which means they are both 180 degrees. So that was just how you prove a triangle has 180 degrees. So to prove it, you need parallel lines, you need transversals, and you need to know about the different types of angles we learned in lesson 12. Take a little bit of a break. I know that was a long activity. That was just a little bit of background about thinking logically and using the angles. We're going to keep using angles. We're going to keep thinking logically to find more missing information, but you might need a little bit of a break now. So pause the video, take a little bit of a break, make sure you understand all the concepts and understand how to work with different triangles and different lines. When you're done with your break, come back to the meeting, come back to the video, and we'll continue the lesson. Okay, class, hopefully you took a little bit of a break after challenge 1 and you're ready to start exploratory challenge 2 on page 138. Now, this little paragraph underneath exploratory challenge 2 is just telling you how they built this diagram right here. It tells you that there's two parallel lines, L1 and L2, so you can see the parallel lines. and there are two transversals. So we have line 1 and line 2, and they are parallel. And we have a transversal M and a transversal N. So parallel lines with two transversals, and it has different points. You see points A, B, C, D, points E, F, G. So there's 7 points, 2 parallel lines, and 2 transversals that cut the parallel lines. You can also see that these 2 transversals, when they cut the parallel lines, made a triangle. And so for part A, our first directions say, name the triangle. Well, to name the triangle, all you do, I just use the triangle symbol, which is just a tiny triangle, and I tell you the letters that make the vertices of the triangle. So for this one, and I usually like to go in alphabetical order. The order of the letters doesn't really matter when you name a triangle. I just like to go alphabetically. So the name of this triangle, if I see the triangle, this is the triangle right here. And the 3 points that make the triangle are B, C, F. So I say this is triangle B, C, F. You can also say triangle CFB, or you can say triangle CBF. There's a lot. There's a few. I think there's I'm guessing 6 different ways to name it. But I usually just like to go in alphabetical order, B, C, F, in ABC order. So this is the one I would pick, although you can do something different if you do a different letter order. Let's look at page 139. Keep page 138 next to you because you need to look at the diagram, but the instructions are on page 139. Here we go. I'm trying to get both on the same. I'm trying to get both of them right here so we can see both. B, name a straight angle that will be useful in proving that the sum of the measures of the angles is 180. So we need a straight angle that will help us, which is, remember I told you a straight angle. To name the straight angle, you just put the angle signal, which is just a small angle, and find 3 points that make a straight line. So I'm just going to go right to the bottom of the diagram here with E, F, G. Because E, F, and G are 3 points and they make a straight line. So I'm going to say angle EFG is my straight angle. Angle EFG is my straight angle. So now I need to prove that this makes a straight line. So let's try it out. Let's try it out. So let's start with my straight angle. And I see, let's do, this angle is going to be blue right here. I'm going to do one blue line for angle BFG. Well, and then I'm going to do a green line. Well, I'm going to do 2 green lines right here. And then for the middle right here, I'm going to do 3 red lines. And you can see right there that blue, red, and green make the straight line. Now I need to also show that blue, red, and green make the triangle also. So here I go. I'm going to say my blue angle, angle BFG, plus my red angle, angle BFC, plus my green angle, angle CFE. All those together, blue, red, and green, equal 180 degrees. So you can see that right there. Because you can see that right there. because those three together make a straight line, so it makes 180 degrees. The next thing I know, the other thing I know, using what I learned in lesson 12, I know that angle BFG right here, my blue one, equals angle CBF, this one right here. How do I know that this one and this one are equal? They are because they are alternate interior angles. So do you see BFG, this blue one, equals this blue one because they are alternate interior angles. Now I have the blue one equal, I have a blue one on the inside of the triangle, and I have a blue and a red and a green making a straight line, and I have a blue and a red on the inside of the triangle. I also need to get the green right here, but I know that this green and this green are equal. I know that my green angle, angle CFE, right here, equals angle BCF. I know that angle CFE equals angle BCF right here. CFE, this one, green one, and this green one are equal, again, because they are alternate interior angles. So now, in my straight line, I have a blue, a red, and a green. And inside my triangle, I have a blue, a red, and a green. Which means my blue, red, and green in the straight line made 180 degrees. So I can prove, because BFG equals this, I can say that angle CBF, I just substitute, plus angle BFC plus, remember CFE is the same as BCF, plus BCF also equals 180 degrees. So this was just practice proving that a triangle has the same degrees as a straight line. The straight line has 180 degrees. And so blue, red, and green make 180 degrees. But I used my angle rules to put a blue, a red, and a green on the inside of the triangle too. So now I know the triangle also has 180 degrees. Blue, red, green make 180. Blue, red, green make 180 degrees. That is proving that triangles have 180 degrees using the angle rules we learned yesterday. So using the angle rules we learned yesterday, now we know that triangles have 180 degrees. And that is how we prove it with mathematical symbols right there. I will leave that on my screen while you take a little bit of a break to think about it, to understand it, and then we're going to come back and we're going to finish the lesson. We're going to talk about the problem set. We're going to talk about the exit ticket. And I will even do some of the problem set with you to help you get started on this work, maybe to explain some things and to fix any misunderstandings you might be having. So take a little bit of a break and then we'll come back and we'll talk about the problem set. Okay, class, that was the end of the official lesson where we used lines and angles to prove things about triangles and straight angles. The lesson summary just kind of tells you what we learned, that all triangles have interior angles measuring 180 degrees. All triangles, the insides make 180 degrees. That was the big idea of today. Page 141 is your exit ticket. This is what you're going to do at the end of the day after you do your problem set and after you check your answers with my answers. So I'm going to post my answers online. After you check your problem set, work on the exit ticket, and then you're going to take a picture of your exit ticket and turn it into the Google Classroom. But you can move the exit ticket away for right now. Page 143 is a homework helper where they ask a question and then they answer it and they show you what they were thinking in the thinking boxes so that you can follow along. They do that on page 143 and 144 are both the homework helper. So if you want some help from the book, read the homework helper. But the problem set starts on page 145, and I thought that today I would do some of the problem set with you on the video just to give you a head start, maybe explain a few things. I probably won't do all of it, but I will do some of it just so you get some practice and you can hear me thinking about things and how I solve these. So if you don't want to check it, if you don't need my help on the problem set, you can turn off the video and you can just check your answers with the ones I post online. But if you like my help, stick around and listen to me talk some more. So for number 1 on the problem set, it says, in the diagram below, AB is parallel to line CD. Very important that they're parallel because parallel means we can use our corresponding alternate interior and alternate exterior rules. They have to be parallel if we want to use those rules. So it's a good thing they told us these are parallel. And then it says the measure of angle ABC is 28 degrees, which they labeled for us. ABC is 28 degrees right here. The measure of EDC is 42 degrees, and they told that, and they wrote that right here, 42 degrees. And then it says, find the measure of angle CED. So what I like to do for this, I like to put a question mark at angle CED so I remember where I need to, what I'm looking for. So angle CED, remember I need to, I find C, go to E, go to D. So C, E, D. E is in the middle. So I need that angle right there. That's the angle I'm looking for. Well, how do I find that angle? Well, let me show you, because this is a logic puzzle, and it does take some practice, so please pay attention. What I'm going to use this angle right here, angle ABC, 28 degrees. I'm going to make that red. Now that red angle right there, I'm going to use my alternate interior angle rule. Because alternate interior angle tells me that angle ABC equals angle DCE. Look at this. This angle right here, because this is the transversal, I know is the same as over here. These angles are the same because of the alternate interior angle rule. So now I know this angle is also 28 degrees. But how does that help me find the blue angle right here? Well, you know that all triangles equal 180 degrees. All triangles equal 180 degrees. So I'm making this angle blue, this angle green. So if all triangles equal 180 degrees, then the three angles on the inside should equal 180 degrees. So the red angle plus the green angle plus the missing blue angle equal 180 degrees. Red, green, and blue equal 180. We proved it in the lesson today that it always has to equal 180. So the red I found out was 28. The green they told me was 42. And the blue I don't know yet. I'm just going to pick a variable and I'm going to say is X. You can use whatever variable you want. Now it is simple algebra that you were doing in even fifth and sixth grade. So you add the two pieces, 28 plus 42, which is 70, plus X equals 180. So the first thing we do is we add 28 plus 42. Now we have 180 equals 70 plus X. So what we do is we do minus 70 to both sides to get the X by itself. 70 minus 70 is 0. So 0 plus X is just X. That's how we get X by itself. 180 minus 70 is 110. So X is 110. So the missing angle is 110 degrees. So we say angle CED equals 110 degrees. So we used the alternate interior rule to find this red, and then we used some algebra skills from 5th and 6th grade to find the missing one. That is exactly how you solve number 1, and that is the answer to number 1 right there. Let me do number 2 for you also. On the bottom of the next one on page 145, let's try this one a little bit, see if I can help you with this one. In the diagram below, AB is parallel to line CD. And remember, very important that they're parallel because that lets me use my angle rules. They have to be parallel for me to use my angle rules. The measure of angle ABE is 38 degrees. So I'm going to do the 38 degrees. And once again, I'm going to color code it to be 30. So this is 38 degrees right here. And they label it for me. And the measure of angle EDC is 16 degrees. So right down here, they label it for me. I'm going to color it green. Right down here, 16 degrees. So that's my green one. There's my red one. Find the measure of angle BED. So that's my blue one. BED. Where's BED? BED. So I actually need to find this one right here. This is BED. This is the blue one. So it's a little bit different from number 1. Number 1, we were finding the one inside the triangle. Number 2, we're finding the one outside the triangle. Might be a little bit more tricky. In fact, there's actually only one extra step. There's only one extra step. So what we do, use the alternate interior angle again. So alternate interior angle tells me that the red one right here, angle ABC equals, remember this one right here, alternate interior angle, equals this one right here, alternate interior, equals angle BCD. BCD. So I know this one is 38. This one also is 38 degrees. Now, the next step, excuse me, the next step is just like number 1, find this missing one right here, which I'm going to do orange. Find the orange one right here. And I'll show you why in just a minute. When you find the orange one, it'll help you. So you know that the triangle 180 degrees equals the red plus the green plus the orange. So you know it's 180 has to be 38 for the green, for the red, 16 for the green, and X because we don't know the orange. The orange is unknown. So we use our algebra skills again. We add together the 38 plus the 16, which is 54, plus the X. So 54 plus X equals 180. And then remember, we do minus 54 from both sides to get the X by itself. This gives us X by itself because 54 minus 54 is 0. And then 180 minus 54 is 126. So we know this missing one right here is 126. Now, you might be saying, Mr. Barrow, how does that help us find the blue? Because remember, we did not care about the orange. The question says find the blue. Well, it does help you because if you look, the blue and the orange together make a straight line right here. The blue and the orange together make a straight line. See, I'll even help you out. I'll turn the page. Do you see right here how the blue and the orange make a straight line? Which means the blue plus the orange make a straight line. And you know from your notes, you know from rules that a straight line is 180 degrees. So the blue and the orange make a straight line. The blue and the orange make 180 degrees. So now you know the orange is 126. The blue is unknown. Let's make it a different variable. Let's do y. So you know this plus 126 equals 180. So how do you get y by itself? You do minus 126 from both sides. So you find out that 126 minus 126 is 0, so you get y by itself. And 180 minus 126 is 54. So now you know the blue is 54 degrees. So the question, what is the angle of angle BED? You say angle BED equals 54 degrees. And that is the answer to number 2. Took one more step. You found the orange, and then you used the straight line rule to find the blue. So this is kind of a little logic puzzle. We're using the angle rules for lesson 12 and using the straight angle rule and the triangle and the 180 triangle rule to help you find missing measurements. It's kind of a little puzzle, kind of a little mystery, kind of a little logic treasure hunt. But you should see how I started with alternate interior angles to find the red on here. Then I used the red and the green and the 180 to find the orange. Then I used the orange and 180 to find the blue. It's multiple step problems, but you can do it. It's multiple step problems, but you can do it. Number 3 on the problem set is a lot like those. It says it says we have parallel lines. It gives you angle ABE, but you have to fill it in yourself. It gives you angle EDC, but you have to fill it in yourself. And then it says it wants you to find angle BED. So it wants you to find this angle right here, which I'm going to color blue. Now you might be saying, how do I find that angle? Well, the first thing you're going to do is you're going to finish the transversal. Like right here, BE, I'm going to stretch it out to make it a transversal. And now you're going to see how it looks exactly like numbers 1 and 2. So I'm not going to do number 3 for you, but it is exactly like number 1 and 2. You just have to make you just have to finish the transversal, and you have to label it yourself. They don't label inside the angles for you. You have to do that yourself. So number 3 is going to be just like number 2 on page 145. Number 4 is, this is a little bit easier because it says, what is the measure of angle ACB? What is the measure of this one right here? What does this equal? What does the blue equal right here? Well, you know that all 3 measurements, a triangle makes 180. So remember, you need the 3 different angles to make 180. Well, they give you 2 of them. They give you, like, this one right here is 64, so you can say 64. This one right here is 83. The only one you're missing is down here, which just give it a variable name. So I'm just going to say x. Now this is just algebra, like we did for number 1 and number 2. You just have to finish the math. So you do 180. You add first 64 plus 83, which is 147. 147 plus x makes 180. So to get x by itself, you just do minus 147 to both sides. Because 147 minus 147 makes 0, so x is by itself. 180 minus 147 is 33. So you know this angle right here, angle ACB, equals 33 degrees. Because that's the missing one to make 180. Remember, the trick is just to make 180. So that's how you do number 4. And number 5, exactly the same way. Page 147, number 6, exactly the same as number 4 and 5. Number 7 is a little bit tricky. Let me show you, because if you look right here, they don't give you any numbers. They just give you variables. They give you x, x, x. So do the same thing. 180 equals x plus x plus x. 180 equals x plus x plus x. You have 3 x's. Now I'm going to stop there because I think you can figure out how to get x by itself and tell me what all the angles are going to be. For number 8 is exactly the same. They just put in this little box here. But that little symbol, that little box there, you should remember from previous grades, that means a right angle. In fact, they even tell you it is a right triangle. So this is a right angle. And in your notes today, I told you what a right angle is. How many degrees is a right angle? So go back and look at your notes and find out how many degrees this is, and then use the same algebra to find this one. Number 9, they want you to find a missing measurement. So this is going to be using the same rules before. Now, it might help you right here to spin your paper and make these lines parallel. You might even spin it this way to see the triangle they're talking about right here. But you can put your paper whatever way to understand. But they are asking you to find angle JMK, which JMK is this one right here. They want you to find that blue angle down there. So you're going to have to use one of your angle rules from yesterday. I'll give you a hint. It is not going to be the alternate interior angle this time. Well, there's more than one way to do this. The fastest way, I think, to do this is to, I'll give you a hint, look for a corresponding angle. Use your corresponding angle rule first to solve this one. But remember, my answers to all of these are going to be posted online in the Google Classroom, so you can always try it, check my answers, and then see if your answers match mine. But that's the end of the problem set. Remember, after you check your answers on the problem set, go back and work on the exit ticket, and the exit ticket is what you turn in today. The problem set is practice to make your skills strong. The exit ticket is to prove to me that you did the practice. Thank you for being here for today's lesson. I'll see you for the next lesson.